KCET 2026 aspirants, so welcome to the Sankalp batch, and today we are going to test what we have studied in the last 5 classes. So yes, we have completed the electrochemistry chapter. I know all of you have done it. So now we will be solving the KCET PYQs of last 10 to 12 years. Okay, so this will give you an understanding whether whatever things, theories, the concepts that we have studied, whether with applying that we are able to solve the questions or not, right? So students, see, in the exam the most important thing is to solve the questions. How much you have studied, revised, make notes, nothing matters if you are not able to solve the question. So in this video I want you people to sit with a pen and a notebook, see the question, solve it, comment the answer, and then see the solution. Okay, so I want all of you to quickly comment a yes for this and be ready with your notebook, pen, and no calculators. Do the calculation by your own, and just I want everyone to comment the answers quickly so that we can have a something as a test type of thing. We can also test your knowledge, and then you can also give a score to yourselves. There will be almost 35 questions or something, so I think 34-35 questions are there. Just for every correct answer that you are doing, put 1 mark. If there is a wrong question, put 0 mark, and at the end comment me your scores. Okay, so that's all in like the instructions, and I want all of you to strictly follow it so that you can also have a understanding about your level of preparation for this chapter. Okay, so let's get started here. So our first topic is galvanic cell. Okay, so we'll be doing questions from galvanic cell. Okay, the first question is in front of you. For the spontaneity of a cell, which is correct? Okay, so I'm giving you a minimum of 10-15 seconds is required, and this question is on the easier side, and the concept used is spontaneity. Okay, so generally there should not be any mistake if you have understood the concepts properly. For spontaneity of the cell, which is a correct criteria. So I hope all of you just pause the video now, answer the question, and then see the solution. Okay, I'll be doing the solution now quickly. So we have, okay, so what I have to say in the solution, if you know the formula of delta G, that is equal to minus NF E naught of the cell, right? And we know that for any spontaneous reactions, delta G should be negative. So this cannot be there, this cannot be there. Okay, this is there and this is there. Now if E naught of the cell becomes 0, then delta G will also become 0. So that will also be not the criteria. So we should have delta G as negative. And if delta G has to be negative, then E naught of the cell must be positive. Okay, because E naught of the cell, if it is negative, again delta G will become positive, right? So we have 2 criteria: delta G should be negative and E naught should be positive. But in options there is no mention about E naught, so we only need to consider about delta G. It has to be negative. Okay, so that is option number B. Now moving to the second question, which of the following is incorrect in a galvanic cell? So this question was asked in 2016, and I have very well explained you about the galvanic cell. So oxidation occurs at anode, reduction occurs at cathode. The electrode at which electrons are gained is called cathode. The electrode at which electrons are lost is called anode. So you have to tell which is incorrect. Okay, again this question should also take around 10 to 15 seconds. 2016 question, easy question about galvanic cell, and generally you should not be making any mistakes here. Okay, so please now pause the video and comment the answer quickly. So if you have remembered, I have taught you a mnemonic, that is LOAN. What does L stands for? I want all of you to write this comment quickly write down this comment in the this formula or this mnemonic in the comment section, so that you will remember it forever in your life. Okay, so what does L? L stands for left, O stands for oxidation, A stands for anode. Okay, everyone please comment it, write down in the comment section, and you will remember it, I guarantee you that. Okay, so now we know that on the left side oxidation takes place. Oxidation takes place on anode, and in a galvanic cell anode is negatively charged. Now let's see the option. Oxidation occurs at anode. Yes, oxidation occurs at anode. This is a correct statement. We need to find incorrect. Okay, you should be very careful whether it is asking you correct or incorrect. Next we have reduction occurs at cathode. Yes, if oxidation is occurring at anode, reduction will occur at cathode. Next, the electrode at which electrons are gained is called cathode. Yes, if you see the galvanic cell, if you remember, we have a cell like this here and we have a cell like this here. Then we have some external wire here, and this is the salt bridge. So here what will happen, the metals will come out, electrons will be formed here, these electrons will move here, and these electrons will be gaining here, right? So what happens now, here the electrons are released, so this is negatively charged, here electrons are gained, so it is positively charged. So we can see the electrode at which electrons are gained. So electrons are gained on this side, released on this side. So yes, at the cathode, this is correct. The electrode at which electrons are lost is called cathode. No, electrons are lost here, right? Means you can see, if for example Zn is there, right? Zn loses its electrons to the rod and come out as Zn2 plus. So at this electrode, electrons are lost at anode. So this has to be anode for the correct statement. Okay, so this is the incorrect statement, option number D here. Yes, now how many of you have given the answer correct? Please put a 1 mark for yourself and 0 for the wrong answer. Moving to the third question here, we'll go to the next topic, that is electrode potential. Okay, we have next topic is electrode potential. We have some questions on this. So 2023 question, a recent question. Consider the following electrodes, okay, and the reduction potential in volts of the electrode is in the order. Okay, so you have been given with a silver plus to silver electrode, and the reduction potential E naught value is given to you, and you need to predict the order of the reduction potential. Okay, so this question, please take some time, and this is on the moderate level question, and this you may do a mistake in understanding the question. Okay, how to approach this question might be a problem for some of the students. So but you can take at least 1 to 2 minutes in solving this question. So now please pause the video, start solving it for 1.5 minutes, and then you need to try this question with me. So I will start solving here, all of you should pause it. Okay, so I have here Ag plus electron gives me Ag, right? What is the value of E of the cell? E naught minus 0.059 by n, n is 1 here, log of 1 by Ag plus, right? This is my equation. Ag by Ag plus, Ag concentration will be considered as 1. Okay, now what happens? See, if the concentration of Ag plus is too high, okay, if this concentration is high, then what will happen? So let me just tell you, if Ag plus concentration is high, then what will happen? 1 by Ag plus value will decrease, right? This whole number will decrease. That means this log value will also decrease. 0.0 means, just a minute, after that I can write, if this number becomes a smaller number, then log of this one will also become a smaller number, right? Then this whole number that you are multiplying, this also becomes a smaller number, means you are subtracting a smaller number from this one, right? E naught minus a smaller number. Okay, so that means if you have smaller number here, E value will be higher. If this number is big, then E value will be less. So for example, we have considered that E naught value is 0.8, right? E naught value is 0.8 minus, we have to do something. These concentrations that is mentioned, that will be affecting this term, right? So now suppose if this term is in one of the option, you are getting this term as 0.4, and in another option you are getting this term as 0.2. So where the E naught value will be higher? E naught, this is 0.6, this is 0.4. So E naught value is higher here, right? So my point is, when you have this number to be very small, then E value will be higher. And when this number will be very small, if the Ag plus concentration is high. If Ag plus concentration is high, this whole decimal becomes a smaller number, log of that one becomes a smaller number, 0.059 into that number becomes a smaller number, E naught minus this will become a bigger number, because you are subtracting a small number from this E naught value. So I need that if Ag plus concentration is highest, that will have the maximum potential value. So where E naught value is highest, 0.1, right? So that is option number B. So I have only one option where B is highest. After that I need to have 0.01, right? After that 0.001, and lastly I have 0.0001. So answer has to be option number A. Okay, so I'll just explain this with more numbers if you want. Okay, just let me erase and show you. For option number A, what I will get, E value is equal to 0.8 minus 0.059, I'm just taking it as 2 log of 1 by, what is here, 10 to the power of minus 4, right? So this goes up, so it will give me 0.8 minus 0.03 log of 10 to the power of minus 4 will become 4, then this 4 will be multiplied here, right? Next, for option number B, you can see this will become for option number B it will become 0.8 minus 0.03 into, here in place of this one I'll put 10 to the power of minus 1, that goes up, it becomes log 10, and log 10 value is 1. Okay, next I will have option number C, where 0.8 minus 0.03 into, here I have log of 10 to the power of minus 2, that goes up, and then 2 will be there, so we will have into 2, and then option number D will be 0.8 minus 0.03 into, here I have 10 to the power of minus 3, it goes up, and here it will be 3. So now you see, here you are subtracting a biggest number, right? So this value will be the least one, so A has to be the lowest value. Here you are subtracting a smaller number, 0.03 into 1, you are subtracting a smaller number, so this will be the highest. Then you are subtracting next smaller number here, so B, C, D, A. Okay, so that is why we have option number A here. I hope you are getting this one. Okay, so please put down in the comment section if you have understood this question. Now let's move to question number next question. So this is also a 2025 question. Okay, recently this year paper question. For a given half cell Al3 plus 3 electrons give aluminium, on increasing the concentration of aluminium ion, the electrode potential will. So just now we have discussed what will be the E of this one. We have E naught minus 0.059 by 3 log of 1 by Al3 plus, right? So if Al3 plus concentration, is increasing, okay, that means this whole number will decrease, log of that number will decrease, you will subtract a smaller number, so I will say that E value will increase. So that is option number 3, that is E value will increase. Just you can see a similar type of question has been asked in 2025, where you need to understand the relation between the concentration and the E value. Okay, so whenever we are increasing this concentration, this overall term becomes a smaller number, we are subtracting a smaller number from here, so E value will increase. Okay, next, moving to next topic is our Nernst equation. Okay, so all of you have studied Nernst equation. What is Nernst equation? Let us revise here once. E of the cell is equal to E naught minus 0.0591 by N log of products ions divided by reactant ions to the power of X or to the power of Y, where X and Y are the coefficients of the equation. Clear? Fine. Next, I have question number 4 here. Cr2O7 2 minus plus 14 H plus 6 electrons give 2 Cr3 plus 7 water. Concentration of E naught value is given to me, Cr2O7 concentration is given, and Cr3 plus concentration is given. E value is 1.067 volt. The pH of the solution is nearly equal to, you need to find the pH of this solution. Okay, so okay, fine. What is pH here? How to calculate pH? So we have studied Okay, so this question was asked in 2014, okay, and this was a slightly difficult question because the formula that we need is not directly from the chapter electrochemistry. It requires a formula of the ionic equilibrium chapter. Okay, so I'll be taking you through that, and you may have questions like where you may do a calculation error here. Okay, and this question you can easily spend 3 to 5 minutes. Okay, so first of all, let me tell you what is the formula for pH. Minus log of H plus. Okay, so I need this value of H plus from my Nernst equation. How will I get that? So if you see E naught value, E value is equal to E naught, like first let me write the equation, minus 0.059, I'll take it as 0.6, okay, for easy calculation. Again, number of electrons involved is 6, right? Log of products divided by reactants ion. So product side I have Cr3 plus, okay, and what else you can see? 2 is the coefficient, right? Next you have Cr2O7, okay, and then you have H plus to the power of 14. Okay, so this is the value that we want. Clear? Okay, so now if I see what is the E naught value, 1.33 minus, here I have 0.01, then I have log, what is Cr3 plus, it is 15 square I can put. Next I have Cr2O7, it is 4.5, okay, and next I have this H plus to the power of 14. Okay, I'll have to keep this as it is. Now what I can see here is, if I solve this, 15 ones are 15.3s, right? So I can write this as 3 by 10, so 3 by 150, so it will become 350, right? So I got here 50 by H plus to the power of 14, right? Okay. So now let's move to the next slide. I'll just keep this calculations on the next part. So what I have, E is equal to 1.33 minus 0.01 log 50 by H plus to the power of 14, right? This I have got. Okay, so now we can solve this part. Okay, so first of all we can write this is as 1.33 minus 0.01. This can be written as log A by log B, log of H plus minus log of 50, log of 50 minus log of H plus to the power of 14. Now from where I have derived this one? So this comes from this log of A by B is equal to log of A minus log of B. Okay, one more rule I want to add here. If I have log of X to the power of Y, that is equal to Y log X. Okay, so now if I want to add this, I'll become 1.33 minus 0.01 log 50 minus 14 log H plus. Okay, this is the thing. Now we need to find this log 50 value. Okay, so you should be remembering log 2 to log 9 or log 10 value. Okay, so log 5 is 0.693. So now we need to solve this log 50 value. Okay, so log 5 is 0.69 something. So I'll just solve this one. Say log 50 I can write as log 5 into 10, right? Then I can write it as log 5 plus log 10. Log 5 is 0.69, log 10 is 1. So I'll get 1.69, which I can roughly write as 1.7. So here I have 1.33 minus 0.01, and this side it is 1.7 minus 14 log H plus. Okay. Fine. Now let's multiply this one. So I know it is taking a bit of time because I'm solving each and every step. In this exam, you don't have to write these many things. You can directly do the calculation part. Okay. So what I have 1.33 minus, if I multiply this one here, I'll get 0.017, right? Minus, here I will get minus this will become plus, and I have plus 0.14 log H plus. Okay, so now let's solve this. I have E value was also given to me, right? E value is 1.067. So let us keep this one also here, 1.067. Where I am getting this, it is given in the question. Fine. Now let's solve this part. So I have 1.33. So let me slightly erase some of this part which I have already discussed, so that I'll get some space for the calculation. Yes. So now if I see, I'll do 1.33 minus 0.017. So that means give me 1.323, right? And this 1.323 I can again do like this, 1.067 is equal to 1.323 plus 0.14 log of H plus. Okay, so now I have this 1.067 to be subtracted on this side. So I have 1.323 minus 1.067. Okay, so I have 13 minus 7, that is 6 here, 11 minus 6, I have 5 here, and then I have 2 here, right? Yes, 0.256. Okay, so that is minus 0.256 is equal to 0.14 log of H plus. Then what I'll do, this I can divide this side, this minus will go that side, so that I will have this equation like this. Again I want to erase this part. Okay, yeah, just a minute. Okay, so I have 256 by 14.256 divided by 14 is equal to log of H plus minus log of H plus, right? So you can see, you can just divide this one, 256 by 1000, we have 14 by 100, right? So I have 256 divided by 140. Okay, so 1, I have to take 1 only because 14 2 is 280, right? So I'll have 140 here, 6, then I have 116, again I can go this side, and if I take 9, so 9 4s are 36, 9 will be higher, I can take it as 8, 8 0s are 0, 8 4s are 32, 8 1, okay. So I'll get 1.8 something. So 1.8 is equal to minus log of H plus, right? Now I told you this minus log of H plus is what? That is nothing but pH value, right? This minus log of H plus is nothing but pH value is 1.8, which can be rounded off to 2, right? So now if I see my options, it is nearly equal to 2. So option number A is the correct answer. I hope you got it. A little bit lengthy question, but yes, there will be certain questions in physical chemistry which will require some time. You have to give that time to those questions. Okay. Moving forward to the next topic we have is equilibrium constant. Okay, we get a lot of questions on this particular topic. So what is our formula for equilibrium constant? Let's quickly revise here. I have E naught of the cell 0.059 by n log of K. Okay, see, fine. Now let's go to the next question. H2 plus AgCl gives you 2Ag plus 2HCl. E naught of the cell at 25 degrees Celsius is 0.22. The equilibrium constant at 25 degrees Celsius is, okay, just a minute. Okay, So H2 plus 2 AgCl gives you 2 Ag plus 2 HCl. E naught of the cell is 0.22 volt, the equilibrium constant in this. Okay, so we know all of us that the formula I have already told you. Okay, so in this how many electrons are involved, that you have to check properly. So what exactly is happening? See, Ag plus is getting converted to Ag, right? So AgCl, it is Ag plus, so I can write the reduction reaction or the cathode reaction is like this. 2 Ag plus gives 2 electrons to give 2 Ag, right? So what is the so what is the total number of electrons involved in the cathodic reaction? 2 electrons. The same will be involved in anodic also. You can see here H2 is there, right? H2 will release 2 electrons to get converted to 2H plus. Okay, so we have this concept of 2 electrons, or this n value is 2 here. Okay, so let's now try this question. We have here E naught 0.22. Okay, we have 0.059. Okay, n value is 2 again. Then I have log of k. Okay, now let me just round it off to 0.06 for easy calculation. Okay, so I will have 0.03. So if I divide this one, I will have log of k is equal to 0.22 divided by 0.03, and this will give me around 7 point something. Okay, 7 point, I think 3 7s is 21, right? 7 point something I will get. Okay, 7 point x. Let me just write down like this. So how will I find out the option? I need to find this k value. Okay, you don't have to find log k value, you have to find the k value. So what is, so if log of k is equal to x, then k will be equal to 10 to the power of x. Okay, so I have log k is equal to 7, that means k will be equal to something equal to 10 to the power of 7.x. Okay, so now if I further solve it, I'll get 10 to the power of 7. So if I write this one, I can write this one as 10 to the power of 7 plus 0.x. Okay, if I add this, I'll get 7.x, and that can be further written as 10 to the power of 7 into 10 to the power of 0.x. You don't have to worry about this part, but you know that the power will be in the form of 10 to the power of 7. So I have here only one option with 10 to the power of 7, so I'll get 2.8 into 10 to the power of 7. So whatever was this value, its antilog value would be 2.8, which we don't have to find it, right? So that is why you can solve this question very easily without going to that part. 2.8 into 10 to the power of 7. If this part is not clear, let me just explain once again. If you have 10 to the power of a into 10 to the power of b, you can write it as a plus b. Okay, so 7.x I was having, so I wrote that 7 plus 0.x, and now I can write them separately, 10.7 into 10 to the power of 0.x. Right, this value we don't have to see because there is only one option with 10 to the power of 7. If there would be two options with 10 to the power of 7, you need to find this. Now question may arise how to find it. Antilog values will be given to you, you don't have to worry, with that you can find that. Okay, next we'll move to question number 6. This is from 2020 question. E naught value for Fe plus 3 to Fe plus 2 is given 0.76, and E naught value for I2 to I minus is plus 0.55 volt. The equilibrium constant for the reaction taking place in the galvanic cell consisting of 2.303 RT above 2 electrodes is. Okay, so you have to find the same equilibrium constant. So first we know the formula for equilibrium constant. E naught of the cell is equal to this much. But here I am not given with E naught of the cell. So this question is slightly on the moderate side because you have to calculate the E naught value also. After calculating that, you need to calculate the log or K value. How will you calculate E naught value? So E naught of the cell is equal to E naught of cathode minus E naught of anode. Now cathode is somewhere reduction takes place, anode is somewhere oxidation takes place, right? So how will you know where oxidation is taking place, which one is undergoing oxidation, which one is undergoing reduction? So you can see that here the reduction potential from +3 to +2 of Fe is 0.76 volt and the reduction potential of I2 to I minus is 0.55 volt. Whose reduction potential is more? Fe reduction potential is more. If Fe reduction potential is more, that means it will undergo reduction easily. So that will be the cathode and this will be the anode. So what we will have here, that is 0.76 minus 0.55. So I will get 21. Okay, so I got this E naught value as 0.21 is equal to 0.06, that is your this value, and N value is just a minute. Okay, we need to find the N value also. So you can see here Fe, so the reaction that is happening at cathode or the reduction part, Fe plus 3 will gain 1 electron to become Fe plus 2. And if I talk about the anode, it will undergo oxidation. So here what will happen? I minus will 2I minus will lose 2 electrons to get converted to I2. So the number of electrons should be same. So here you should multiply 2 so that both the equations will have same number of electrons. So what is my N value? N value is now 2. Okay. Next we have log of K. Okay. So I can cancel this one easily. This is 0.3. 21 by 3 will give me 7. So I have 7 is equal to log of K. Next, if I want to take antilog, K will be equal to 10 to the power of 7. Okay. So what will be the value here? Option number D. Okay. Next, question number 7. For a cell involving 2 electron changes, E naught value is 0.3. Then the equilibrium constant is. Again, very similar question. We just have to use the same formula. So E naught value is 0.3. Okay. And here we have 0.06 by 2. Okay, I have rounding of this 0.059 to 0.06, and we have the electron 2 electron changes given by log of K. So we will have 0.03. So I have here 0.3 by 0.03 equal to log of K. Okay, so I have 3 by 10 and 3 by 100. Okay, so it becomes 3 by 10. So I will just write it like this for my convenience, by 10, and so you can see here we will have log K is equal to 10, right? So I have log K is equal to 10. What is K here? 10 to the power of 10. Okay, that is option number D. Next, moving to next topic, that is Faraday's law. Okay, so here a lot of questions will be asked for you from Faraday's law. So what are this Faraday's law? Let's quickly revise. M is equal to Z into I into T, where Z is equal to what? Molar mass divided by N into 96500, okay, into I into T should be in seconds. Okay, fine. Let's see the first question here. So this question was in 2025, recent year question. So you need to match the following and select the correct option for the quantity of electricity in coulomb mole inverse required to deposit various metals at the cathode. So you have to deposit, for example, Ag plus. Okay, so for Ag plus, what will be the reaction? Okay, so this means 1 mole of electrons, or I can say 1 Faraday, and 1 Faraday means 96500 coulombs. So this one will be here 96500 coulombs. Next you have Mg2 plus. For option number B, if you have 2 plus, it will require 2 electrons for Mg. That means it is 2 Faraday, right? Then how many coulombs? 2 into 96500, right? That means 1900 something will get, that is this one, right? Next, if you see aluminium 3 plus, similarly aluminium 3 plus, right? right? We'll require 3 moles of electrons or 3 Faraday. So 3 into 96500, that will give me 28,000 something. So this is the option. Next, Ti4 plus will require 4 times 4 moles of electrons. So this one will be this one. So I have A3 and there's only one option with that, A3, B4, C2 and D1. So option number A is the correct answer. Moving to the next question here. We have 1 liter of a solution of MgCl2 is electrolyzed completely by passing a current of 1 ampere for 16 minutes and 5 seconds. The original concentration of MgCl2 solution was. So what is happening here? Just let's first visualize the question, or let's first understand the question. So you have a solution, okay, you have some electrodes here, okay, and the electrolyte present here is MgCl2. Now what will happen? See, Mg2 plus is there, it will go and deposit. This is your positive electrode, this is negative electrode. So Mg2 plus will go and deposit here. Completely electrolyzed means all the Mg2 plus went and deposited there. So our question is the original concentration of MgCl2, means how much Mg went and deposited, that much mass of Mg must be present here, and we need to find the concentration of that. Okay, so let's solve this now. Okay, so we have we have this formula of M is equal to Z into I into T. So I'll be solving that here. What is the mass deposited? I have to calculate. What is the molar mass of magnesium? 24. Okay, then N. So Mg2 plus will gain 2 electrons and will convert to Mg. So N factor will be 2, right? Then I have into 96500. Then I have I, current here is 1 ampere, okay, and I have 16 minutes and 5 seconds. So 16 is 16 into 60 is 960, 960 into 5 is 965 seconds. Okay, so you can see how we can cancel this one. So this will become 12, okay, and this one I can cancel. So I'll get 0.12 grams. So how much mass of magnesium is deposited? 0.12 gram, or that much gram of magnesium is present in the solution. Now can we calculate the molarity? Molarity is equal to what? Because it is in terms of molarity. Molarity is what? Concentration or number of moles in 1 liter of the volume. It is already, volume is 1 liter. We just need to calculate the number of moles. So 0.12, let me just see, 12 divided, cancel, we have 0.12, right? This 9, yeah. So I have 0.12 by 24, okay, into or 1 liter. So that will give me 12 ones are 1 by 2. 1 by 2 is 0.5 into 10 to the power of minus 2, or I can write 5 into 10 to the power of minus 3. So the molarity here will be option number A. Moving to the next question here, the charge required for the reduction of 1 mole of MnO4 minus to MnO2 is. This is also from Faraday's law. Just need to calculate the oxidation state till here. So MnO4 minus, what is the oxidation state? MnO4 minus, if you see here, the oxidation state is +7. Okay, you can just take this as AX. This is 4 into 2 minus 8 is equal to -1. That gives me +7. And I have here MnO2, which is in +4 state, right? So +7 to +3, it is 3 Faraday, or 3 electrons are required, or 3 Faraday. That is option number B here. Next we have, by passing the electric current, NaClO3 is converted to NaClO4 according to the following equation. How many moles of NaClO4 will be formed when 3 Faradays of charge is passed through NaClO3? So now if you see the oxidation state of NaClO3 here, NaClO3 to NaClO4, right? Okay. What's the oxidation state of chlorine here? Let this one be +1, this is x and this is minus 6. So I have here plus 5. And here also if you see x plus 1 plus x minus 8, that will minus 1, this will become plus 7, right? So I have here, just a minute, yeah. So I have here plus 7, plus 5 to plus 7, which is 2 moles, right? So the loss of 2 moles of electrons are there, right? Plus 5 to plus 7, 2 moles of electrons have been lost. So I can say that if 2 moles of electrons are lost, okay, or 2 Faraday of current is required for this transformation. If 2 Faraday of electricity is given, then 1 mole of NaClO4 is formed, right? So for 1 Faraday, how much it will be? 1 by 2 moles. Then I have for 3 Faradays if it is given. So you will have 3 by 2 or 1.5, that is option number C. Okay. Next, we'll move to question number 11. The amount of current in Faraday required for the reduction of 1 mole of Cr2O7 ions to Cr3+. So if you see Cr2, this is also very similar to the previous question, Cr2O7 to Cr3+. So first of all, you should know that the 2 chromium should be balanced in both the sides. Here I have 2 chromium, here I should also have 2 chromiums. Okay. So now what is the oxidation state of chromium here? So let it be 2x minus 14 is equal to minus 2. I'll have x is equal to plus 6. Okay. So plus 6 to plus 3 is 3 Faraday, right? How much electrons I should be losing? 3 Faraday. But there are 2 chromiums. In 1 mole of Cr2O7, there are 2 chromiums. So for 1 chromium, if I need 3 Faraday, for 2 chromium, I need to have 6 Faraday. So from Cr of 1 Cr, each Cr is in plus 6 state, plus 6 to plus 3. So you just imagine like this. See, it is giving you 2 Cr3+. Okay, and here this can I write like this? Just like this. Okay, here this Cr is in plus 6, this is also in plus 6. So 1 plus 6 to plus 3, 1 plus 6 to plus 3. Here I required 3 Faraday, here I required 3 Faraday. So in 1 mole of Cr2O7 2 minus, I will require 6 Faradays. So that is option number C here. Okay. Next, moving to question number 12. How many coulombs of electricity are required for the oxidation of 1 mole of water to dioxygen? For 1 mole of water to dioxygen. Okay. So if you see here, what is the oxidation state of oxygen here? We'll forget about hydrogen. It is minus 2. Okay. So O2 minus will release 2 electrons to give you half O2. Is it balanced now? This side minus 2, this side minus 2, this side 1 oxygen, this side 1 oxygen. So how many moles of or how many coulombs are required? 2 Faraday is required. Now 2 Faraday in coulombs will be how much? 2 into this one. So you will have 193,000. So that is 1.93 into 10 to the power of 5. Okay, so that is not B. Be very careful with the options. It has to be D. 1.93 into 10 to the power of 5 coulombs for 1 mole of water. Okay. Next, how many coulombs are required to oxidize 0.1 mole of water? So just now I have seen that for 1 mole how much I required? 193,000, right? That was there. Just let me check. Yes. For 0.1 mole how much I will require? Just put a decimal here. This much I will require. So it is 1.93 into 10 to the power of 4. That is option number B. I am not solving it again. It is just like the previous question. Next, current of 3 ampere is passed through a molten calcium salt for 1 hour 47 minutes and 13 seconds. The mass of calcium deposited is. This is also a very direct formula based question. The only thing here little bit is to calculate this time properly. Okay. So I have mass deposited M is equal to Z into I into T. What is Z here? molar mass of calcium is 40. So just put here 40 divided by N value is how much? Calcium, if you see, the charge is 2 plus, right? So what is the N value here? N value is 2 divided by 96500. Next I have current. Current is how much? 3 amperes. Time. So first is 1 hour means 3600 seconds. 47 minutes I have. I'll convert it into seconds. 24 plus 4. Yeah, that much. 2820. And then I have 13. Okay, 6433. So total time I have is 6433 seconds. Okay, so now let's solve it. So I can divide this one like this. I have 2 ones are 2 twos are. Then I have 2 ones are. Here I have 2 fours are 8, 1, 2 eights are 16. Then I have 2 twos are 4, 1, 5. Yeah, 4, 8, 2, 5. So I have this one. 3 threes are 9, 3 threes are 9, 3 fours are 12, 18 plus 1, 19, and I have 4, 8, 2, 5. Okay. So now you can see it will be what value it can come. Okay. So if you see 3, 4 6 are 24, 30. Can I take 4? 4 5s are 20, 9, 10, 4 6 are 20, 32. Yeah, somewhere around 4 I can get. Say 4825 into 4 will be how much? Okay, 19300, which is very very close, 19299. So if you divide, you will get 3.9 something, or which is approximately equal to 4. So option number D here. Okay. Moving to the next topic is our batteries. Okay. So in batteries, what all things we have studied? We have studied about primary battery, secondary battery, we have studied about fuel cells and hydrogen, last cell was what? Corrosion. Okay, so these all concepts will be covered in this part. So a device that converts the energy of combustion of fuels, actually this is fuels, okay, fuels like hydrogen and methane directly into electrical energy is known as, we have studied, this is fuel cell, which uses the combustional energy to convert into electrical energy. Moving to the next question, in a dry cell, which of the following is the electrolyte? Dry cell, you remember, Leclanche cell. So here we use ammonium chloride as the electrolyte, and ammonia gas was used to produce. Now comment down and tell me what happened to that ammonia gas which was released in this reaction. I'll give you a hint, it forms a complex, but what was the complex and what is the formula of that? Quickly comment down and tell me. And by this time out already we have, I think, done 17 questions. Numbering is slightly different. 2 questions I have not given number, I think. So 17 questions are already done. Just put down, just see how much you have scored. Just count your scores quickly. Okay. Moving to the 17th question here. In fuel cells, dash are used as catalysts. A very direct question. Platinum and palladium, I have told you, is used as a catalyst to extend or to increase the absorption of hydrogen and oxygen gases. Next we have a secondary cell is one which can be recharged by passing current in the same direction, can be recharged by passing current in the opposite direction. Okay, option A is also correct, but whenever you have more than one correct option, you need to find out the most probable options. Okay. Sorry, yeah. So it is option number C here. Next we'll have 19th question, while charging the lead storage battery. This is important question. So now see, while charging, that is the reverse process. Okay, lead battery is a rechargeable battery. In lead battery, what happened at anode? Okay, at anode what happened? Pb got converted to PbSO4. Okay, and here at cathode, PbO2 got converted to PbSO4. And this is the original reaction for lead battery while discharging. Okay, so now what will happen when you recharge it? This reaction will reverse now. So here this reaction will take place. So I'll just change the color here. So when you when you recharge it, this one will get converted and this one will get converted. So now PbSO4 is in +2 oxidation state and this is in 0 oxidation state. So here reduction is happening. So now this reaction will become cathode part, or this reaction is taking place at cathode now, and this reaction, that is +2 to +4, which is oxidation, that is taking place at anode now. Right? So what is the first option? PbSO4 on the cathode is reduced to Pb. Yes, that is happening. PbSO4 on the anode is oxidized to PbO2. This is also correct. PbSO4 on anode is reduced to Pb. No, first of all, at anode there is never reduction, there is always oxidation. PbSO4 on cathode is oxidized to Pb. So this is also not correct, okay, because PbSO4 is +2 and this is 0. So this process is not oxidation, it is a reduction. So the correct answer here we have is both A and B. Okay, both A and B are the correct statements. Next, question number 20. In H2O2 fuel cell, the reaction occurring at cathode. So what gas was present at cathode? Oxygen gas is given at the cathode side. Okay, so you can see the reaction I have written here. At cathode, oxygen gets reduced to 4OH minus. So I have this first reaction here, which is option number A here. Okay, so that is a direct question. You should be knowing this reaction. Let us see the next question here. For the hydrogen oxygen fuel cell at 1 atm and 398 Kelvin, delta G value is given. E naught for the cell is approximately. So we have this direct formula. E naught of the cell and delta G relation is minus NF E naught of the cell. Right? We need to find this E naught value. We have the formula in front of us. Delta G value is minus 240 kilojoule is there. Please convert it into joule. So I'll write 240 into 10 to the power of 3. N value is what here? This is very, very critical. See, if I show you the previous reaction, right, 2H2 plus O2 gives 2H2O. This is the reaction. So for 2 moles of H2 and for 1 mole of O2 gives you 2 moles of water, the number of electrons involved is 4 moles, right, for 2 moles of H2. But if you see in this reaction, this is half of that, right. We have reduced H2 from 2 moles to 1 mole. We have reduced oxygen from 1 mole to half mole and water from 2 mole to 1 mole. So if the number moles has become half, the number of electricity required will also become half. So for 2 moles of H2 we required 4 electrons. For 1 mole of H2 I will require 2 moles of electron, or N value will be 2, right, minus is there, 96500 into E naught. This minus will get cancelled here. So now if I want to solve this one, 240 into 10 to the power of 3 divided by, I have 2 divided by 96500. Okay, so here I can write this as 1000. Okay, I'll cancel these 2. Then I have 5 2s, I have 5 193, I have 2 and I have 120. So I have 240 divided by 193. Okay, so 240 divided by 193. So that's obviously it will take 1 here. Then I will have 10 minus 3 7. Then I have 13. 13 minus 4 will be 9. Then I will have, that's all, right? Yes, 470 again. So I should consider 3 will not go, 1.2 something I'll get, which is option number B. Okay, I have 1.26 also. So we have to go a little bit more. 2 3s are 6, 2 9s are 18, 2 1s are 2 plus 1 3. I have 10 minus 6 4. 16 minus 8 is 8. Then again I have 840 here. So here you have to check. 4 9s are, if you take 6 9s are 54, 6, it will become more. So it will definitely be 4, option number B here. Next we'll see question number 22 will be from the next topic, that is electrolysis. Okay, just a minute. So the next topic we will have electrolysis. Okay, so here if I see, yes, during the electrolysis of brine solution using inert electrodes. Now brine solution means aqueous solution of NaCl. Okay, so what is liberated? So if you remember, we have what is during the electrolysis of brine solution by using inert electrodes. So we have here Na plus and Cl minus, right? This moves towards the anode. Okay, and this moves, this is positively charged, so this moves towards the cathode. Okay, and this is negatively charged, so this also moves towards anode, which is positively charged. So here we have sodium is deposited at cathode. Then let's see the options here. Oxygen is liberated at anode, that is not there. H2 is liberated at anode, no. Chlorine is liberated at anode. Sodium is deposited on cathode. So when it is given brine solution, okay, brine solution is, again I forgot here, you have to add H plus and OH minus. So at cathode what happens actually, hydrogen gas is produced. Okay, so hydrogen gas is produced at cathode, so this will not happen. So option number C, Na deposits on cathode, Na deposits at cathode is not there because hydrogen will get deposited at cathode. Chlorine is liberated at anode. Okay, so we have option number D here. Next, moving to question number 23, if an aqueous solution of NaF is electrolyzed between inert electrodes, the product obtained at anode is. So you have aqueous solution of NaF. So I have H plus, I have OH minus, you have Na plus and you have F minus. Okay, aqueous solution of NaF is electrolyzed between inert electrodes, the product obtained at anode is. So here we have this one positively charged, so this will move towards cathode, and here we have negatively charged, so this one will move towards anode. Okay, so we have, if this solution is there, what is obtained at anode? So OH minus will obviously undergo oxidation, and here we will get O2 gases produced. Okay, next question number 24, an aqueous solution of copper sulfate is subjected to electrolysis using electrode solution. Using electrodes, the pH of the solution will. Now if you see, you have copper sulfate, right? Cu2 plus will be there and SO4 2 minus and H plus and OH minus. So if you see, Cu2 plus reduction potential is 0.34 and H plus reduction potential is 0.00 volt. So now this Cu2 plus, okay, this one will undergo reduction. If this one will undergo reduction, then you will have, because its reduction potential is higher, so copper 3 plus reduction potential will be more, so H plus concentration in the solution will be more. If H plus concentration increases, then pH will decrease. So that is why pH will decrease. Okay, more is the H plus concentration, lesser is the pH value, right? Minus log of H plus. So that is why this will decrease. Next, in the electrolysis of an aqueous sodium chloride solution, which of the half cell reaction will occur at anode? So you have aqueous sodium chloride, so you have H plus, you have OH minus, you have Na plus and you have Cl minus, right? So you have now which of the half cell will occur at anode? So this is your anode. Electrodes positively, oh sorry, one second. Yeah, these electrons will move towards cathode and these electrons or ions will move towards the anode. This is negatively charged, so they will move towards positively electrode. These are positively charged, so these will move towards the negative electrode. So what reaction will happen at the anode? So we sorry, we have chlorine will get oxidized to give you half chlorine, that is option number A here. Next we have questions from conductance topic. Okay, very important one. So let's see. The electronic conductance depends on, so this is 2025 question. Now electronic conductance means what? The metallic conductance. Okay, it depends directly on the number of valence electrons, so option number A. Okay, Next, specific conductance of 0.1 m HNO3 is this much. Molar conductance is how much? What's the formula for specific conductance and molar conductance? We have molar conductance is equal to kappa into 1000 by C. So what I can write? Lambda m is equal to, what is kappa value? 6.3 into 10 to the power of minus 2. Okay, just a minute, I'll write here. Okay, 6.3 kappa into 1000 by C. C is 0.1. Okay, so I have 63, this goes 630. Okay, so that is 630 ohm inverse centimeter square mole inverse. Okay, next we'll see the molar conductance of maximum is for which concentration. So if you see molar conductance, we have kappa into 1000 by C. Okay, so if molar conductance should be high, then we have concentration should be less, then only molar conductance will be high. So in which case we have this one, that is B, option number B. It has the least concentration, so molar conductance will be maximum in this option number B. Next, we'll see the resistance of a 0.01 m KCl solution at 298 Kelvin is 1500 ohms. If the conductivity is given as this much, the cell constant you have to find out. Okay, so we have this formula. I can write like this: R is equal to rho into L by A. Okay, or I can write 1 by rho, which is equal to kappa, is equal to 1 by R into L by A. Okay, so I have 1 divided by R. What is the resistance given here? 1500. Okay, fine. And what is kappa value? Kappa value is 0.1466 into 10 to the power of minus 3. Okay, and this is cell constant or G star. Okay, so you have to just multiply 1500 on this side. Okay, so that if you multiply this one to this one, you will be getting 0.219. Just calculate this, you will see that will give you option number A. Okay, next, moving to question number 29, the pair of electrolytes that have the same value of A. So this I have discussed in one of the questions in the sessions also. If the cation and anion charges are same, then they will have the same A value. As you see here, NH4 is plus, Cl is minus, Na plus is 1 and Br is also minus 1. So this is also 1,1 type electrolyte. This is also 1,1 type electrolyte. They will have the same A value. So option number A here. Next, we have the value of A in the equation is same for the pair. Again, similar question. Here it is plus 1 minus 1. Here it is plus 2 minus 1. So these are not same. Okay. Here if you see Ca plus 2 chlorine is minus 1. Mg is plus 2 sulfate is minus 2. So this is also not correct. Here I have plus 1 minus 1 plus 1 and minus 1. So yes, these both are 1,1 type. So they have the same I can say A value. So option number C here. Next, question number 31. At a particular temperature, the ratio of molar conductance to specific conductance of 0.01 m NaCl solution is. So we have this one, lambda is equal to kappa into 1000 by C, right? So we have the ratio of molar conductance to specific conductance, right? So ratio of molar conductance by specific conductance will be equal to 1000 by C, right? So 1000 I have 10 to the power of C and concentration I have 10 to the power of minus 2, that will give me 10 to the power of 5. Okay, so option number D is the correct answer. Clear? Okay, so yes, I think that's all in this class. We have done so many 31 questions, 31 plus actually. Some questions I have not numbered, and I hope that you have enjoyed this session. If you have any doubt in any question, you can put down, and I also want you to put down your scores. Okay, so how much plus you are getting, and if you have any other questions or anything doubt is there, that also you can comment down. So I'll be taking the name of all those students who have answered correctly in the next video, who have got the highest marks. I'll be taking it in the next video. So please comment down your scores, and thank you for watching and all the best.